All right, so this is the key to some other problems that we've looked at. So if you look at number 40, you want to find the difference quotient for this function. And my function is f of x equals negative 3x squared plus 5x plus 2. So remember the difference quotient's this. It's f of x plus h minus f of x all divided by h. Now remember, when you're doing this, everything you write has to be mathematically correct. All right. Now some of you have a habit of putting equal signs all over the place when subsequent expressions that you write are not really equal to each other. So that's why in class we broke it down to steps so you wouldn't have that issue. So step one is to find this part of the numerator. So my difference quotient is all this part that's in the numerator divided by h. So in the numerator you have f of x plus h, then you have f of x, and then you're subtracting those two. And then at the end you're going to be dividing that by h. Okay, so step one is to find this first part. So you're going to say step one, find f of x plus h. All right, so we're going to say, well, that's going to equal then. Here's my function f, and wherever you see the variable x, you're going to substitute x plus h. So notice what I'm going to write is mathematically correct. So you're going to say negative 3 times x plus h squared plus 5 times x plus h, and then plus 2. All right, so wherever I saw that variable x, I substituted x plus h. That's what that means, right? I see it here, and I see it here. So you're going to substitute x plus h. Okay, now you got to use the order of operations, so you are expected to get rid of those parentheses. Well, one of the things you learned was that when you square a binomial, you get a trinomial. So you have x plus h times itself, right? So when you square a binomial, you get a trinomial. So you have the using the fall method, the first x times x is x squared. The outer x times h is xh. The inner, that's an h here, the inner h times x is also xh. And then the last, h times h is h squared. Also, one of the things you learned was that when you square a binomial, the outer and the inner are exactly the same. So then when you combine this, you're going to get x squared, and then there are two of these xh terms, so plus 2xh, and then plus h squared. So when you square this x plus h, you get this trinomial. So I'm going to replace this with this trinomial. So I get equals negative 3 times x squared plus 2xh plus h squared. And then I'm going to go ahead and distribute this since this is being raised to the first power. So I get 5x plus 5h, 5x plus 5h, and then plus 2. So remember, always do the order of operations. So it was incorrect to have distributed negative 3. You would have gotten the wrong answer. So you got to do the exponent first before you multiply. So notice you may say, well, you didn't do exponent here. Well, remember, x plus h to the first power is what? X plus h. So it's nothing to do. Here, there is something to do. You got to multiply that factor by itself. Okay, then when I distribute here now, I get negative 3x squared. Negative 3 times 2xh is a negative 6xh. A negative 3 times h squared is a negative 3h squared. And I'm going to write all these terms over. All right. Now, these terms, there's nothing in common. You can go through here and you'll notice that none of these terms are like terms. All right, now that's your step one. Equal, equal, equal. That's mathematically correct. This expression is equivalent to this expression is equivalent to this expression. Okay, now step two. Step two, then you're gonna do this whole numerator. So you're gonna say this minus this. So step two is you're gonna say let's find now f of x plus h minus f of x. All right. So f of x plus h I already found, that's this right here. So this is going to equal now what I just found up here, negative 3x squared minus 6xh minus 3h squared plus 5x plus 5h plus 2. And then you're going to subtract this function f of x. Now parentheses are needed here because that function has more than one term. So you got to put that in parentheses. If you don't, you're going to get a wrong answer. So you're subtracting all of f of x. So you're going to say minus 3x squared plus 5x plus 2. Now get rid of the parentheses. So either distribute the -1 or take the opposite of each term. So I get equal negative 3x squared minus 6xh minus 3h squared plus 5x plus 5h plus 2. And then the opposite of a negative 3x squared is a positive 3x squared. The opposite of a positive 5x is a negative 5x. And the opposite of a positive 2 is a negative 2. Now at this point, when you do step 2, at this point, meaning step 2, meaning f of x plus h minus f of x, then every term that does not have a factor of h, its opposite will be there, and when you add them up, you get 0. For example, this term does not have a factor of h. Its opposite is here, so negative 3x squared plus 3x squared is 0. This has a factor of h, this has a factor of h, this does not. 5x, negative 5x. Those add up to be 0. This has a factor of h, this does not. Positive 2, negative 2. So the only things left, the only terms left would be terms that have at least one factor of h. Okay? Now at this point what I would do is since I'm going to go ahead and divide by h in step 3, let's go ahead and factor out the h here. Those three terms have the GCF being h. So I'm going to say h times negative 6x. Make sure you write this correctly. Don't put an h here and then cross it out. That's incorrect. Some of you are doing that. Take the time and write it out. What you write has to be what we would do as math students. Minus and then h times 3h. That's what you have to write. And then so h times negative 3h is negative 3h squared, and then h times a positive 5 is a positive 5h. So that's what you would say. Now step 3 is where you take the numerator, which is what this is right here. This is your numerator. Okay? And you divide that by h. That's what that says. Okay? Numerator. So step 2 divided by h. And now these h's divide out, and you get negative 6x minus 3h plus 5. And so what you found here is this. The difference quotient, E-N-C-E, difference quotient of f of x, which equals, what was it? It was negative 3x squared plus 5x plus 2, is this expression, negative 6x minus 3h plus 5. Okay? All right, so notice the steps. Step 1, step 2, step 3. If you can do it in steps, in that procedure, knowing that procedure should help you to get all your points for this. Just be careful here because some of you want to take the easy way out and not actually write this correctly. You get the same answer, but somewhere in here you're not writing it correctly. So take out the h and remember what that means when you factor out an h. This times this is this. All right. So on the worksheet that dealt with that, make sure you look at the worksheet because some of you that are trying to take the easy way out, I made comments and I showed you why you didn't get full credit. So make sure you go back so you don't make the mistake on a test. All right, so that was 40. All right, 41, you're given a piecewise function and you want to find each of those functional values here. So you're told f of x is equal to 3x minus 1 if my x, the part of the domain I'm using, is greater than 3. If x equals 3, then my function is going to be x squared. And if x is less than 3, my function is going to be 5x plus 2. So here, I want to find f of 5. Remember, f of 5 means what is the y value when x is 5? Well, I got to find out where x is 5 is located. So obviously, when x is 5, 5 is greater than 3, right? So that's when you're going to use. So you're going to use, for that one, you're going to say that's going to be, this one you're going to use, 3x minus 1. So you're going to say 3 times 5 minus 1. So that's 15 minus 1, which is 14. So f of 5 equals 14. That's 14. Okay? F of negative 6, you're going to find out which one of these you're going to use. So if x is negative 6, See, this is x negative 6, right? Then that's the one where negative 6 is located. Negative 6 is not greater than 3. Negative 6 is not equal to 3, but negative 6 is less than 3. So this is when you're going to use. So you're going to use 5x plus 2. So now this is going to equal 5 times x, which is negative 6, plus 2. 5 times negative 6 is a negative 30, plus 2, which is a negative 28. So f of negative 6 equals a negative 28. And then finally, f of 3. So in this case, x is 3. So determining which one of these you're going to use is going to be this one, because that's the one that says you're going to use this if x equals 3. And x is indeed 3. So you're going to use x squared. And so if x is 3, you're going to say 3 squared, which is 9. So f of 3 equals 9. Okay? All right, 42, you want to find the average rate of change. Remember, the average rate of change is the idea of that slope of this function in the interval negative 3 to 4. And so to find the average rate of change from x equal negative 3 to x equal 4, so x equal negative 3 to x equal 4, remember average rate of change, same thing as slope, same idea of slope. So the average rate of change, remember we talked about slope, you subtracted the y coordinates in the numerator and subtracted the x coordinates in the denominator, right? So here are my x coordinates. You're going from x equal negative 3 to x equal 4. It does not matter whether you put negative 3 first or 4 first. Usually students will uh, take the second x value. So you're gonna, now remember, be careful, that's not a point. So don't think of this as xy. That's part of my domain going from x equal negative 3 to x equal 4. So you're going to say 4 subtract a negative 3. That's what you're going to write. 4 subtract negative 3. But if you're going to put 4 first, you got to find the y value associated with 4. So then you're going to go up here and you're going to say, well, I'm going to find f of 4. Then I'm going to subtract. You subtract. Remember, slope, change in y over change in x. Then you're going to subtract the y value associated to x equal negative 3. So that means you're going to find f of negative 3. So that's what you have to write. Now you go off to the side and you do the work. So let's go ahead and find f of 4. So f of 4 means that I'm going to go to my function f, and where we see the variable x, I'm going to substitute 4. So I get 4 times 4 squared minus 3 times 4 plus 1. 4 squared 16. 16 times 4 is 32. Remember, you do the exponents first before you multiply. So 4 squared 16. 4 times 4 is 16. That does not mean 4 times 2. It means 4 times 4. And then 16 times 4 is 64, right? 4 squared 16. 16 times 4 is 64. Negative 3 times 4 is a negative 12, and then plus 1. And then use your calculator if you need to. 64 minus 12 is, what's that, 52? And then 52 plus 1 is 53. So that's f of 4. So I get 53, subtract. And then you do the same thing for f of negative 3. Let me go and put that here. So f of negative 3 is going to be, wherever you see the variable x, you're going to substitute negative 3. So I get 4 times negative 3 squared minus 3 times negative 3 plus 1. Negative 3 squared is 9. 9 times 4 is 36. Negative 3 times negative 3 is a positive 9, and then plus 1. And we add those up, 36 plus 9 plus 1, you're going to get 46. So that's going to be 53 minus 46 divided by, and then 4 subtract a negative 3 means 4 plus 3. So 53 subtract 46, when you do that, you're going to get a positive 7. And then 7 plus 4 is 11. So you get 7 11s. So that's your average rate of change. So the answer, you're going to say equals 7 divided by 11. Okay? All right, now in 43, that's where you have to start looking at the idea of transformations. And so the problem says, for each function, describe how you would transform the parent function to obtain the desired function. That's the function I want to use. So I want to eventually graph this function and graph this function using the parent function. All right, well, remember, you're looking at the absolute value of x here, the absolute value function here, and this is the quadratic function. So whenever you're looking at the absolute value function, the parent function, the basic function is going to be y equal absolute value of x. So that's your parent function. Absolute value function, absolute value of x. Quadratic function, your parent function, will be y equal x squared. Okay? That's a quadratic function, your parent function, your basic function, the one you begin with. So I begin with absolute value of x, I begin with x squared. Okay, now notice you have some transformations here. So when you have a number on the outside, that's a vertical translation. Either you go up or you go down. When you have a number on the inside of the parent function, see x minus 2, that negative 2 is on the inside, plus 4, that plus 4 is on the inside. When it's inside, you have a horizontal translation. And if you have a negative on the outside of the parent function, that's a reflection about the x-axis. That's a reflection about the x-axis. Okay? So let's look at part A. So your words are going to say this. So your words are going to say, and you always go from left to right. Go from left to right. So you're going to say start with absolute value of x. Okay? And then you're going to look at this. So this is a horizontal translation. Now, in the lessons, you learned that the horizontal translation is the hardest one to figure out because it's not intuitive. So you have x minus 2, but when we graphed x minus 2, it was really shifting the, in this case, absolute value of x, shifting the parent function to the right 2 units, not negative, not to the left 2 units, but to the right. So you're going to start with absolute value of x, then shift absolute value of x to the right 2 units. Okay, once you shift to the right 2 units, then the rest of this is easy. You're taking, remember, plus 7, that's that vertical translation. So since it's plus 7, you're then going to shift it up 7 units. Then shift up 7 units. Okay? So in terms of a graph, this is what it looks like in terms of a graph. So let's look at this. So here is the parent function. So remember, when you're graphing the parent function, absolute value of x, so graphing absolute value of x, y equals absolute value of x. So let me write it out again. Y equals absolute value of x. When graphing that, you're going to start with the parent function. So when x is 0, y is 0. So get the origin. When x is 1, the absolute value of 1 is 1. So we get 1, 1. When x is negative 1, so looking at the t-table, 0, 0, 1, 1, negative 1, absolute value of negative 1. Remember saying absolute value of negative 1. Absolute value of negative 1 is 1. 2, absolute value of 2 is 2, right? Negative 2, absolute value of negative 2 is a positive 2. So notice um, the 1, 1, negative 1, 1, 2, 2, negative 2, 2, and so on. So when you plot those points, you get something that looks like this. Negative 1, 1, negative 2, 2, 3, 3, and so on. Negative 3, 3. And when you graph this, you get this. So the absolute value function is a V. The shape is a V. You have two rays that connect at the vertex here. And in this case, the absolute value function, the vertex is at the origin. All right. So that is the absolute value of x. Okay? That's what the absolute value of x looks like. Now, what I want you to do, though, is to use this to help you graph this. So it says graph the function. So the next thing I had to do was I had to shift the absolute value of x to the right 2 units. So you're going to take every point, and you're going to shift it to the right 2 units. That's what makes this easy. Once you graph the parent function, the rest is easy. So take the vertex, shift it to the right 2 units. 1, 2. Take this point, shift to the right 2 units. 1, 2. Take this point, 1, 2. Then go on this side. Take that point, shift to the right 2 units. Right 2 units, and then right 2 units right here. And now that part will then look like this. So here's the vertex right here, and we get this. All right, now you got to label this. So this one here is absolute value of x. This here is absolute value of x minus 2. So make sure you label this correctly. So this part right here represents this piece right here. So this piece of g of x right here is this. And then finally, that says once I graph this part, then I'm going to shift it up 7 units. So now you're going to take this and you shift it 7 units. So you're going to, let's start with the vertex. You go up 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Oops. Let's do it again. 1, 2, 3, 4, 5, 6, 7. And then you could do, remember it's a V, right? So you really just need 2 points here. And then go over here. 1, 2, 3, 4, 5, 6, 7. And then this right here is, g of x. So that's g of x. So g of x is the absolute value of x minus 2 plus 7. Let me go ahead and write it out a bit better. So g of x is equal to the absolute value of x minus 2 plus 7. So notice I did this in transformation. So I graphed the parent function first, then I did the first transformation, which is a horizontal one, and then always do the vertical translation last. Always, always do the vertical translation last. Okay, that's important, especially if there were any stretching or shrinking, which we don't have here, but if there were, if you did not do the vertical translation last, you would get a wrong graph. All right, always do the vertical translation last. So you're gonna go up 7 at the end, your last step, and you're gonna go down 3 as your last step. Okay. All right, so that's what you had to write. Okay, now let's look at this one. So your parent function here, your parent function is x squared. So you're gonna say start with x squared. All right, and then you go from left to right. So remember, there's a negative out here outside the parent function. That's a reflection about the x-axis. So you're going to say start with x squared, reflect it about the x-axis. Reflect about the x-axis. Okay. Then here's a horizontal. Remember, counterintuitive. Then you're going to shift it to the left 4 units. Then shift to the left 4 units, and then your vertical translation, that's easy, then shift down 3 units. Then shift down 3 units. Okay? All right, now let's take this information and let's graph the quadratic function. Okay. All right. Okay, so here is your x squared. So we got to graph x squared. So remember, doing a t-table, if you need to use a t-table, if x is 0, 0 times itself is 0. If x is 1, 1 times 1 is 1. If x is negative 1, remember what that means. Negative 1 means negative 1 times negative 1, right? Negative 1 squared, so that's a positive 1. When x is 2, 2 squared is 4. When x is negative 2, negative 2 times a negative 2 is a positive 4. When x is 3, 3 squared is 9. And then negative 3, a negative 3 times a negative 3 is also 9. All right, and I'm going to stop here because it only goes up to 11. So when I graph the parent function, I get 0, 0, which is here. I get 1, 1. I get negative 1, 1. Okay. I get 2, 4, which is here. And I get 3, 9, which is here. Same thing on this side, negative 2, 4, negative 3, 9. And so when I draw this, remember it's a curve, it's a parabola, so make sure it looks like a parabola, not a V, okay? Make sure it looks like a parabola, just like this, and then do this side. And remember, x squared is symmetrical about the y-axis, so make it look symmetrical about that y-axis. That's important. Okay, so make sure it looks symmetrical about that y-axis. All right, so there's your vertex. Okay, now let's go ahead and do the steps. So now I graphed x squared. Now, see that's negative out here, so that means reflected about the x-axis. So every point on this graph, I'm going to reflect about the x-axis. Okay, so 0, 0 is at the origin, it stays there. 1, 1 reflected by the x-axis becomes 1, negative 1. Negative 1, 1 becomes negative 1, negative 1. See, reflecting about the x-axis. 2, 4 becomes 2, negative 4. Just like this. This point here, right here, becomes this point here, reflected about the x-axis. And then the other one we had was 3, 9. So 3, 9 becomes 3, negative 9. Negative 3, 9 becomes negative 3, negative 9. And then you do the same thing. So you're going to graph it, make sure it looks like a parabola, except this time it's going down instead of going up because of the reflection. So just kind of do something like this. Take your time. It could look a little bit better here. Look something like this, and then do the same thing on this side, just like this. Okay. All right. So that right here, and by the way, label this. So this is x squared. This will be negative x squared, right? Okay. Then we're going to shift it to the right, to the left rather, 4 units. So I'm going to take this part here. I'm going to shift it to the left 4 units. So this origin, go to the left. 1, 2, 3, 4. This point here, go to the left 4. 1, 2, 3, 4. This point here, 4 units. 1, 2, 3, 4. This point here, so these are your little key points that you have that you can use. 1, 2, 3, 4. 1, 2, 3, 4. Go over here. 1, 2, 3, 4. 1, 2, 3, 4. Okay, and then you draw your graph again, just like you were doing. Okay, right here. Okay, and then something like this, right? Do the same thing on this side. Erase if you have to. Something like this. All right. Now label this. Now remember, to get this, I took negative x squared and I shifted to the left 4 units. So that means this. So this is now negative in parentheses x plus 4 squared. Okay? So remember, horizontal translation is counterintuitive. So don't say x minus 4 because you said, well, I went to the left 4. The horizontal translation is counterintuitive. You need to be careful with that. And then finally, you're going to shift it up. Oh, I'm sorry, shift it down 3 units. You're going to take this piece here, shift it down 3 units. And I'm going to go ahead and try and use maybe a highlighter for that part. But let me go ahead and put the points. So if I take the vertex and I shift it down 3 units, I get 1, 2, 3. This point here, which was right here, 1, 2, 3. This point here becomes 1, 2, 3. Over here, 1, 2, 3. This point right here becomes 1, 2, 3. So you have a lot of points all over the place, so just be careful. 1, 2, 3. All right, and so when I trace this, I'm going to get, make sure I did this correctly. Okay, that goes here. Oops, I forgot to do this point here. 1, 2, 3. Okay. So now I can do a better job with that. So I'm going to go ahead and kind of do something like this. Okay. It's right here. Go to this one now. Don't go to this one. That was on that other one. And do the same thing here. And so that's it. So the green is your final one. So you're going to say f of x equals. So remember, this is what you want to eventually graph using transformations. So you can say negative x plus 4 squared minus 3. And that was it. So that is some problems on using transformations. And then we also talked about piecewise function, average rate of change, and difference quotient. All right, so that is the end of the key to those problems.